Alright, so let's consider this situation where we have a car driving along at a constant speed of 25 meters per second around a flat, unbanked curve of radius 220 meters. We want to know what the minimum coefficient of static friction that's necessary to keep it on the road is, and we want to know if we had only 1/3 that value, how fast could we go around the road safely? So let's shrink this down a little bit. So we know what's happening is that we're moving around a circle. We know that the main force holding us inward is friction. And we want to know how big that friction is so we can figure out how big mu s is. Now, what we do know is we know the velocity, or the speed, is 25.0 meters per second. We know the radius of curvature is 220.0 meters. We know it's unbanked. And I can draw a side view, a cross-section here. There's the car, and I can identify forces on it. I can identify a normal force upward. I can identify weight down, and there's a frictional force pushing me inward. All right. So in the vertical direction, I write my sum of forces. I get N minus mg equals may, which is 0. And in the x direction, I get frictional force equals ma, which is equal to mv squared over r, because v squared over r is my acceleration in a circle. Please note, a lot of people try to write this one this way. They'll say F minus mv squared over r equals 0. For our purposes, that's wrong. There may become times later on in your career where you treat things like that and treat this fictitious force as if it was there. But we want to really get in the habit of recognizing that this acceleration it's an acceleration, and so it belongs on the right-hand side of the equation. So to come around the curve safely, we need a frictional force equal to mv squared over r. I can't get an actual number because I don't know m. In the pinch, I could make one up and just use that, say, on a test, because I don't know it. But let's see whether or not we really need it. We also know from the y equation here that the normal force is just equal to the weight in this case, because it's not accelerating upward or downward. And we know that the force of static friction is less than or equal to mu s times n. So mu s must be greater than or equal to the force of static friction divided by the normal force. And that is mv squared over r divided by mg. And you'll notice now that the mass cancels out here. So it turns out I didn't need that. I know that mu s is going to simply equal v squared over r g. So let's do that. Mu s equals v squared over rg, which is, I believe we said 25 meters per second. 25 meters per second squared divided by 220 meters times 9.8 meters per second squared. Let's take a look at our units for a moment. This is meters squared over seconds squared, meters squared over seconds squared. Units all cancel out. Bringing up our calculator again, I have 25 squared divided by 220 and divide that by 9.8. Aha! I need at least 0.289888. Okay, so that really is at least 0.290. Okay. Now what if I have a mu-s that's only 1/3 that value? Mu-s is 1/3 of 0.290. Well, I can just get that value and calculate from there. .966 or 0.0966. Then we know that the force of friction is equal to mv squared over r, as before, and that is always less than or equal to mu-s times the normal force, which in this case is mg. That tells me that v is going to have to be less than or equal to mu-s g mu-s gr square root. And I can plug in numbers and get an answer there. Now, that'll give me a perfectly good answer, but let me show you another option. Suppose I called this mu-s naught and this v naught. Then in this case, v is equal to the square root, or is less than or equal to the square root, of mu-s gr, but mu-s is 1/3 of mu-s naught. So this is the square root of mu-s naught over 3 gr, and I have an equation for mu-s naught. So that is square root of v naught squared over 3 rg, because v naught squared over rg is mu-s naught. Multiply that by gr. Notice much of this cancels out now. And I find that my maximum velocity is just 1 over root 3 times my original velocity that I calculated before. That value, 25 divided by 3 is 14.4 meters per second. So that illustrates some of the power in not putting in numbers too soon.